You are at the window seat on a snowy morning, and a vehicle with a long arm is spraying your wing with something orange. Then it does a second pass with something green. And then, nothing. The aircraft joins a queue and sits there, and the snow keeps falling on the wing that was just cleaned. I'm Alex, and this is Unseen Systems. Somebody in that cockpit is now watching a clock, and the clock is the only thing standing between this aeroplane and a very old kind of accident. Here is why anyone cares. A wing works by keeping air attached to its upper surface, and that attachment is most fragile right at the leading edge. Put a rough layer there, not a block of ice, a rough layer, and drag goes up, lift goes down, and the angle at which the wing stops flying comes down to meet the angle the aircraft rotates to on takeoff. The aeroplane can be flown perfectly and still not fly. A mechanical engineering professor who works on exactly this puts a number on how much you lose.
Snow and ice on airplane wings can decrease lift by as much as 30%.
So step 1 is removal, and it is done with heat more than chemistry. The orange fluid is a glycol and water mix with nothing thickening it, sprayed on hot, around 140 to 150 degrees Fahrenheit. It melts what is stuck there and flushes it off the back of the wing, taking the contamination with it. And then, because it is thin and hot and unthickened, it runs off too. Within minutes there is very little of it left, which is why there is a second pass at all, and why the two passes have different names. The first one is de-icing, it takes off what is already stuck there. The second is anti-icing, and it goes onto a surface that is already clean. Removing and protecting are two different jobs, and no single fluid does both well. So the green fluid goes onto a wing that is already clean. Its job is not to remove anything. Its job is to sit there, and to do that it has thickening polymers in it, which give it a property that sounds like a contradiction. It is stiff when nothing is moving, and it goes thin the moment something shears it. Parked at the gate, it behaves almost like a gel and stays exactly where it was put. And now the part that reframes what that fluid actually is. It is not a shield. Snow landing on it does not bounce off, it sinks in and dissolves. The layer absorbs the precipitation and gets progressively more watery, more dilute, less able to stay liquid at the outside temperature. The fluid is not being attacked, it is being used up. It is a consumable spread out across the wing, quietly spending itself while the aircraft waits. Which raises an obvious problem. If it is engineered to stay on the wing, how does it ever get off? The same way it stays on. As the aircraft accelerates, the airflow shears it, and shear is exactly what makes it thin, so it lets go, but not at a threshold. It sheds progressively as the shear builds through the takeoff roll, and there is no published speed at which a fluid leaves a wing. What exists instead is a test. Fluids are run through an aerodynamic flow-off test, banded by how fast the aeroplane rotates. A high-speed band above about 100 knots, a middle band from 80 to 100, and a low-speed band from 60. A fluid is approved for the class of aircraft whose test it passes, and the thickened fluids typically do not pass the low-speed one. That is why a thinner version exists at all, for aircraft that leave the ground more slowly. So the fluid has to be matched to the aeroplane. One that has only ever passed the fast test has never been shown to clear the wing of a slow one. So the fluid is designed to fail. That is not sloppiness, that is the specification, and here is where it gets genuinely uncomfortable. Everything else about this aircraft is instrumented: fuel temperature, hydraulic pressure, the angle of every control surface. But there is no sensor that tells anybody the state of the fluid on that wing. It does not fail at a threshold you can see. It just gets thinner, and at some point a patch of it freezes and nothing in the cockpit changes. So aviation did the only thing available. It replaced the measurement with a clock. There is a published set of tables, reissued every winter, broken down by fluid type, by outside temperature, by how dilute the fluid was when it went on, and by what is falling out of the sky. Some fluids carry extra axes of their own. The thickened ones are tabulated brand by brand, and the thin thickened one adds the aircraft's rotation speed and the temperature the fluid went on at. You look up your row and your column, and you get a number of minutes. The federal operating rule that defines that number, they call it holdover time, is careful about what it is promising.
The estimated time de-icing anti-icing fluid will prevent the formation of frost or ice and the accumulation of snow on the protected surfaces of an aircraft.
Estimated, and every cell in that table is a range, not a figure, with two separate warnings attached. Heavy weather, heavy precipitation rates, or high moisture content will shorten the protection. High wind, jet blast, or blowing snow may reduce it below the lowest time in the range, may, not will, because nobody is promising you where the bottom is. The clock also starts earlier than you would expect, not when the spraying finishes, but the moment the final application begins. Everything after that, the pushback, the taxi, the queue, is spending it, and there is not always much to spend. The thin fluid often gives under 20 minutes. In snow, with the air below about -10 degrees Celsius, the protection can be gone in under 5. And because an estimate can be wrong, the procedure does not end with the clock. It ends with an eye. Before takeoff, there is a contamination check of the critical surfaces, somebody physically looking at the wing, and if the holdover time has run out, that check is not optional. The most sophisticated machine most of us will ever sit inside settles this particular question by having a human being turn round and look out of a window. On the 22nd of March, 1992, a Fokker F-28 was de-iced at LaGuardia. Twice, both times with the thin, unthickened fluid, the kind whose protection is measured in a handful of minutes. Then the departure was delayed. Roughly 35 minutes passed between that second spray and the takeoff roll, and it was still precipitating the whole time. The aircraft never established a climb. Of the 51 people on board, 27 were killed, and when the investigators wrote their probable cause, they did not start with the crew. They started with everybody who had failed to give the crew a way to think about a cue. This is how the finding opens.
The failure of the airline industry and the Federal Aviation Administration to provide flight crews with procedures, requirements, and criteria compatible with departure delays in conditions conducive to airframe icing. And the decision by the flight crew to take off without positive assurance that the airplane's wings were free of ice accumulation after 35 minutes of exposure to precipitation following de-icing.
The board did also fault the crew. The report lists their procedures, their coordination, and a rotation below the prescribed speed as contributing factors. But it put those second, and the distinction matters because of what got built afterwards. 21 safety recommendations came out of that report, and the answer was not a sensor and not a coating. It was a procedure, a defined moment when the clock starts, a table that says how long you have, and a rule that when the time is gone, you look, or you go back and get sprayed again. Sit with that clock for a moment, and the whole procedure changes character. The interesting thing about de-icing an aircraft is not that we found a fluid that keeps ice off a wing. It is that we never did. We found one that keeps ice off a wing for a while, and then arranged the entire departure around not knowing exactly how long, because the fluid was always going to run out, and the only real engineering decision left was whether the aeroplane would still be on the ground when it did. So the green fluid on that wing is not protection in the way a coat of paint is protection. It is a timer, spread thin, already counting down before the vehicle has pulled away. Take a window seat over the wing on a snowy morning and watch what the fluid does as the aircraft accelerates. That sheet peeling backwards off the surface is the last thing it was designed to do. Thanks for watching.